merit. So the big thing about Venn diagram is it shows us relationships between sets or between groups. The first thing I want to do is show you sort of my strategy for creating a Venn diagram. And then I don't even know if you're going to have to create one on your assignment. I think it's just like reading them. But that's okay. I think when you understand how to make them, then reading them becomes a little bit easier. So this part right here is it's a Venn diagram that has 3 categories. Now for me, the way I like to approach this is I like to start with the overlapping parts first. So watch this. If you look in the very, very center, this section right here is the section where all 3 categories overlap. So if you go through and read all these descriptions, there is one that says all 3. So right here, it says 6 people like all 3 subjects. So right away I can put a 6 in here. And now we're done with this one. Actually, I'll cross it out when I'm done with it. Okay? Next, I want to do some more overlapping stuff. So I gotta sort of just like pick a part. Doesn't matter which part I pick. Actually, you know what we could do is we can also go from the descriptions. Take a look at these descriptions right here. It's an and part. And guys, in what do you call this? In Venn diagrams, anytime you see and, it's the overlapping part. So it says 18 people like math and science. So check this out. Here's the math circle. And then here's the science circle. Whoa, I missed. Hold on, that was an awful trace. So you see the overlap? The overlap is right here. This entire part right here is the overlap. So it says 18 people like both math and science, but the thing is, since I already have the 6, that means 6 of them are already accounted for. So there should be a total of 18 people. That means that this little section right here should be 12. Because that entire slice of the overlap should be 18 altogether. So let me go into this. I want to delete all this stuff right here. Okay. So now I'm done with this. The next one says 10 people like science and social studies. So let's see. Here's the science circle. And then the social studies circle. I think it's this one. So I'm just looking for the overlap. So the overlap is this part right here. And they tell us 10 people like it. Well, we already have 6 accounted for. So to make it 10, I would just put a 4 right there. Delete all this. And this tracing stuff I do, it's just so I can really get a good look at what the overlap is that I'm trying to fill in. So I'm done with this one. Next, math and social studies. So I got math. And I have social studies. Social studies is this one. So there's my overlap right there. That one says 12 people. So if that's already 6, that means this is 6. Does that kind of make sense how I'm approaching this? Okay. So now we're done with all the overlap parts. Now we can just look at individual circles. The entire circle now. That's all that's left. So this thing right here, this one says 56 people like math. So here's math. This is all math right here. And there needs to be 56 people inside that circle. How do we figure out what goes in this spot right here? So add those 3, and then, yeah, subtract it from 56. What is that, 24? No, I mean, like when you add these. 24, take away 56, it's 32. So there's math. Now we go into science. For my science circle, that total needs to be 43. Same strategy though. That's what, 18, 22, 22, 43, 21, bam. And then the last part, the last circle has to have 35 people in it. There's already 14 showing. Just kidding. 16 showing. So if I subtract that, 19 people. So that's how you fill out a Venn diagram. The next thing we're going to do is read stuff out of a Venn diagram and start calculating probabilities. Hold on, do me a favor. Go back real quick. Put the E on science. I don't know where it went. I had to put it on here after I put it into the smart software. Just add that because it bothers me. I don't know what sync is. Okay. So now using a Venn diagram. Before we use the Venn diagram to answer some questions, I want to just make one up for a second. Because all of the examples, I noticed that all of the examples that I borrowed, they don't always look like the problems. They don't always look like the problems that are in the assignment, so I'm going to make one up. I want to see if you guys can read some information out of here for me. This is going to be about clothes that people are wearing. Well, not the clothes, but the colors that people are wearing. Let's say this is black and this is blue. And I'm gonna say this is 17, this is 4, and this is 8. So I'm gonna ask you a question. What does the 4 mean? They're wearing both black and blue, yeah. Let me ask you this other question. How many people have on blue? There's 12 people, yeah. So when I talk about a specific circle and I say blue, I'm talking about the whole circle. So you have to make sure you add up all the little parts because it's all divided out the way you saw it when we filled out the other one. Here's the part that I want to talk about that is not in the notes, but you need to know. So there's a box sometimes, and then sometimes there's a number out here, like I'll say 10. What does the 10 mean? Yeah. Nope. Not the total. Yes. So the black circle represents people wearing black. The blue circle represents people wearing blue. Anything outside of that is the people that are not wearing either. So they're wearing different colors. So I just wanted you to know that because, like I said, there's some stuff where in the assignment you might see the box, and then sometimes they just leave the box out. So if you're outside of the two circles, that means that you don't belong to either of those two groups. Okay. So now, talking about using a Venn diagram to find some answers here. This says, how many people were surveyed? How do you find how many people were surveyed from a Venn diagram? Just add them all up. Yeah. Add up every single number in that Venn diagram. Someone do it for me. 86? Are we sure? Because the last class gave me like 3 different answers. Someone else do it too, just to make sure. 86? Okay. It says how many people were surveyed. Why is it important to know the total? Kind of, but I mean, think about we're in probability right now, right? Why do you need to know the total for probability? Goes on the bottom, perfect. Okay, so now we're going to start calculating some actual probabilities. And so that means that we know 86 goes on the bottom. So how many people like country music? Good. The other class, at first they thought it was just 17. But when I talk about country music, I'm talking about the whole circle. So country music people, what did you say, 33? Yeah, so you're looking at the entire circle, so you add up all the small pieces. Okay? Next, wait a second. What does and mean in probability? There's 2 different types of probability, right? Or and and. Or is add, and is multiply, but I actually don't want to multiply here. In a Venn diagram, and means something. Okay, watch this. I'm going to go back to the clothes example. How many people are wearing black and blue? So you see where to look? What does and mean then when you're looking at a picture? Where do you look when I say and? Well, Well, kind of in the overlap, right? The part that is shared. So in this question, when it's asking us for the probability of country and wrap, we look at country. Whoa. We look at wrap. And the probability is going to be the overlap of those two. So the bottom is 86. What's the top? What is it? It's 8, yes. Which reduces to 4 over 43? Yes. So there's our answer. Okay, this one, oh my God. In the other class, I messed this one up. So I want to make sure I get this right. So an OR problem. What does an OR problem mean?
What is add?
OR means add, right? So we want to find how many people like country and rap. Oh, sorry, that was the last one. Country or rap. Now there's two different ways you can think about this. You could use the formula. You know how we know those formulas from the other day? So we know an OR formula, we know an AND formula. Let me ask you this question though. Let me go back to the closed one more time. Is this mutually exclusive? No, it's not mutually exclusive because you have people who are in both categories. So that's not mutually exclusive. So in a not mutually exclusive event, you basically add the first probability. So you add all these up. That's your first probability, 21 out of I don't know how many. And then you add these up. But remember, when you counted up these and got 21, and you counted these and you got 12, you counted the 4 twice. So you would have to subtract out the 4. You could do that using the formula, or you could sort of do it this way because it calculates the same thing. So country or rap is basically all of the people with country and all the people that also like rap. So watch this. See, my thing is I want to try to do this straight from the Venn diagram and not have to use a formula. So here's all my country people. That's all my country people, right? But I also want the people that like rap. So isn't that also these people right here? So what do I get when I add all of those up? I'm adding up everything in the red. I'm adding everything up in the blue. 68, yes. What? What did you say? You just looked at it. Yeah.
Yeah.
Oh. I'm just showing you what you're supposed to be counting.
Oh yeah, I know, but yeah.
Oh, okay. What? Was there another comment on this side? Yeah.
So, like, my question is, so you circled it, right?
Yeah.
Why did you choose rap? Like, because you circled
It doesn't matter. No, because look at, let me delete this. Let me delete this right here, what I just did, and do it the other way. If I do all of the rap people, I'm adding up all these numbers, right? And then I'm going to add up these numbers. Aren't they the same exact numbers from before, from the first time? So the order that you do it in doesn't really matter. It'll all add up to be 86 or 68 anyways. Now, if that bothered you and that didn't make any sense, you could always use the formula. You know the formula for not mutually exclusive? The probability of this one plus the probability of this one minus the probability of the overlap. That still works. But when we count it like this, so I had some confusion in the other class. I myself got confused. The confusion happened because we sort of counted all this stuff up and then totally left out the 7 and the 1, which is totally wrong. Then we counted these up and then tried to subtract the 7 and the 1 because of the not mutually exclusive stuff. But that doesn't work because then you never counted 7 and 1. Now, if you look at how I drew this, do you see how the 7 and 1 is only getting counted once? That's why I'm not going to subtract the 8 from the answer. It has to be 68, not 60. So it's all in how kind of like you look at it. And it doesn't matter which one you put first, because in the end, these are the ones that cause the issue right here, and we've got to make sure that they're accounted for. And if we're going to do our formula where we do it separate, be careful, because then you're going to end up counting the 7 and the 1 twice. So in that case, you would have to subtract the 8. This reduces though, right? I forgot about that. 34 over 43. Okay. Next, you can also figure out probabilities from a diagram, a Venn diagram that already has the probabilities inside of it. If you notice, these are two different events. There is some overlap to them, but there aren't just like regular numbers, there's decimals. So that tells us right away that those are actually the probabilities. So if I want the probability of A, what would the probability of A end up being? Okay, let's make sure we're looking at the right thing. I said the probability of A, right? That's all of this. So that's 0.7. What's the probability of B? 0.3. Probability of B is all of this. Okay? What does and mean again? Okay, so first, and is never add, or is add. And means multiply, but we don't have to multiply anything because in a picture, we can find the and by looking at the overlap. Bless you. So our overlap here is 0.2. Okay? The next one, probability of A or B. So we can do it like this. Here's A, bless you. That's A, and then this part right here is the B part. And I'm not counting, I'm like cutting that off because I don't want to count it twice. It was already counted when I counted A. So if I add those up, 0.8. And guys, if you wanted to do the formula, remember the formula for non-mutually exclusive events is probability of A plus probability of B minus the probability of A and B. You can still do that. Watch. 0.7 plus 0.3 minus 0.2. 0.7 comes from here. 0.3 comes from here. And then 0.2 is the overlap that we subtract out because it got counted twice. It's still 0.8 though. However you do it. If you want to use formulas on this one, you can. Now the only one that kind of throws people off is this last one. This last one comes from, remember the decoding problems that we did? It's hard to decode it from this picture though, because this picture doesn't really have any words. But that right there is called a conditional probability. It's saying find the probability of A if B is happening. So I'm going to show you a little trick that I use to remember how to do this from a Venn diagram. So you see that line right there? If you tilt it, do you guys see it as a fraction now? So right here, it's going to be the probability of B on the bottom because that's what the fraction is showing. But the top is actually going to be both. So it's going to be probability of A and B. That's going to be your formula no matter what. The second one always goes on the bottom though. So now let's go back and look at the picture. What's the probability of A and B? What is it? 0.2, so that goes on top. What's the probability of just B? 0.3. So if you type this in the calculator and divide it, it ends up being a lot of sixes, but I'm scared of 3 sixes, so I'll put 0.67. And that's it. That's all you have to know for Venn diagrams. So if you struggle with Venn diagrams, it's okay. The test has one question with the Venn diagram, but you actually don't have to read any information off of it. because there's a sentence right above it that gives you all the information you need anyways. And then you can just use your formulas. Got to remember though, because it happened 3 times already. And is times. And is not plus. We got about 4 days to get that straight before we take this test. So the rest of class, you're going to be doing 9.5. And then I'm going to finish off this answer key so you can check your answers and make sure you're practicing right.